Hello friends, today we will see divergence and curl of a vector point function. In the last lecture we have seen that gradient of scalar point function. Now we will see divergence and curl. So both these operators are operating only upon vector point function, not on scalar point function. So operating upon a vector point function f bar by operator del scalarly, we get scalar point function known as divergence of a vector point function denoted by div dot f bar or del dot f bar, and by operating on f bar vectorially we get vector point function known as curl of f bar denoted by curl dot f bar is equal to del cross f bar. So students, here del is nothing but operator nabla, as we have seen in the last lecture. So first thing is that divergence of a vector point function, let f bar is equal to f1i plus f2j plus f3k, then divergence of f bar is denoted by del dot f bar. Here I have written here. Okay, so del dot f bar is nothing but del is nothing but I dou by dou x plus j dou by dou y plus k dou by dou z into f bar is nothing but given vector f1i plus f2j plus f3k. Now we are going to take dot product. Okay, here it is dot product of two vectors. So kindly observe here, coefficient of I is f1 and coefficient of I is del by del x. That means multiplying these two things together we get del f1 by dou x. Multiplying this quantity with other becomes 0 because dot product of I and j is 0 because these are the perpendicular to each other. Similarly for j into del by del y into f2j is nothing but del f2 by dou y and del f3 by del z is called divergence of vector point function f bar. Now see curl of a vector point function. Let f bar is equal to f1i plus f2j plus f3k, then curl of f bar equal to del cross f bar is nothing but the determinant in which first row goes to coefficient of del by dx del y plus and del by del z. In the second row, so coefficient of I, j, k respectively, and in the third row coefficient of I, j, k from f bar. Okay, so del cross f bar is nothing but the determinant in which first row is I, j, k, second row is coefficient of I, j, k in del bar del, and third row is nothing but the coefficient of I, j, k in f bar. Okay, so we should note two things here. If f bar is a vector point function such that del dot f bar, that means divergence of f bar is equal to 0, then f bar is called solenoidal. And in other hand, if f bar is a vector point function such that del cross f bar equal to 0 bar, then f bar is called irrotational or conservative. That means if curl of a vector point function is nothing but the 0 vector, then we should call that vector as irrotational or conservative. Okay, so let's move to the next. So students, we will see some standard results. First one is divergence of f bar plus minus g bar, where f bar is a vector point function and g bar is also vector point function. Then divergence of their addition and subtraction is given by divergence of f bar plus minus, here minus, which is overlapping on the original line, so plus minus divergence of g bar, or we can say that in another symbol, del dot f bar plus minus g bar is equal to del dot f bar plus minus del dot g bar. So this is simply the additive and subtractive rule of derivative. So much more familiar with the derivative, or so see second number, curl of f bar plus minus g bar equal to curl of f bar plus minus curl of g bar. So this one is also similar to that one. Symbolically we can write del cross f bar plus minus g bar is nothing but del cross f bar plus minus del cross g bar. Okay, now we'll see the divergence of f bar cross g bar, cross multiplication of two vectors. So is nothing but g bar dot del cross f bar minus f bar dot del cross g bar. So this is the productive rule, but here sign is opposite. Okay, so this is not exactly equals the product rule of derivative, so much more similar, but here sign is negative. Now del dot phi is a scalar point function and f bar is vector point function, then its divergence is given by phi into del dot f bar plus del phi into f bar. Okay, so like this. So these are the few standard results for which we are going to see problems. Now problem number 1 is, if f bar is equal to x plus y plus 1 into I plus j minus x plus y into k, then prove that f bar dot curl of f bar equal to 0. So first of all we will note, suppose f bar is equal to x plus y plus 1 into I plus j minus x plus y into k is 1. Now curl of f bar is nothing but, by definition we'll have I j k in the first row, in the second row I j coefficient of I j k in curl or del, and in the third row coefficient of I j k in f bar. So coefficient of in the third row we'll see this one is coefficient of y, this is coefficient of j, this is coefficient of k. Okay, so coefficient of k is here along with minus sign, minus x minus y, so I have written here minus x minus y. Now we'll solve this determinant I into minor this, so here it is del by del y into minus x minus y. So x is constant with respect to y, hence derivative of minus y is minus 1, so minus 1 here. Now minus into del by del z into 1, so 1 is constant, so with respect to z is 0, so here it is only minus 1, minus j into, now let me write next, minus j into this, so this cross multiplication, so del by dx minus x minus y, that means minus 1, and x plus y plus 1 into del by del z, so with respect to z this is constant, so 0, so minus j into minus 1 plus k into, now see the next one, plus k into this, because we are eliminating this row and this column, so del by del x into 1 is 0, del by del y 1, so that will be minus 1 here, and minus I, so this minus minus plus, so plus j minus 1k minus k, therefore curl of f bar is nothing but minus I plus j minus k. Now I'll see f bar dot curl f bar equal to minus, so dot product of this, from equation 1 and 2 we are having minus I into I, that is minus sin x plus y plus 1 plus 1 plus x plus y. So we'll see, after multiplying this minus into bracket, we'll have minus x minus y minus 1 plus 1 is here, plus x, so this is cancel with this one, minus y plus y cancel, minus 1 plus 1 cancel, is equal to 0. So this is the proof. So we are having a problem. F bar is given quantity and we are going to show f bar dot curl f bar is equal to 0. So that we have shown here. Now I'll see the next problem. Problem number 2. Prove that f bar equal to x plus 2y plus az into I plus bx minus 3y minus z into j plus 4x plus cy plus 2z into k is a solenoidal, and determine the constants a, b, c if f bar is irrotational. So let's see solution. Let f bar be the given vector and note it as equation number 1. We know that f bar is a solenoidal if del dot f bar is equal to 0. Okay, so now del dot f bar is nothing but del f1 by del x plus del f1 del f2 by del y plus del f3 by del z. Now del f1 by del x, so f1 is nothing but this quantity, and with respect to x this derivative is 1. Now del f2 by del y means this quantity, and with respect to y this derivative is minus 3, and with respect to z this is 2. So 1 plus 2 is 3 and minus 3 will have 0. So next part is, now f bar is irrotational if curl of f bar is equal to 0 bar, but we have provided us that f bar is irrotational. Okay, let f bar is irrotational, that means curl of f bar is equal to 0 bar. So this is the thing in our hand, and we are going to find the values of the constant ABC. Now curl of f bar, consider LHS. Curl of f bar is equal to determinant ijk del by del x del by del y del by del z. So f1 is nothing but x plus 2y plus az, bx minus 3y minus z, 4x plus cy plus 2z. So we'll solve this determinant c. Here it is minus 1, so I into c minus 1 minus j into, so it is 4 minus a plus k into b minus 2. So I into c minus 1 plus j into a minus 4. So here we have taken minus sign outside, so that I can write here as it is, plus k into b minus 2. From equation 2 we have curl of f bar is equal to 0 bar. So in LHS I have written here 0 bar equal to 0i plus 0j plus 0k into, sorry, is equal to I into c minus 1 plus j into a minus 4 plus k into b minus 2. This implies that c is equal to minus 1, a is equal to 4 and b is equal to 2. So these are the values of constant. Okay, so along with this we will stop here. Until then, keep read these notes. Okay, thank you.